Hi, I'm Chelsie Czop. I'm a senior product manager with Google Cloud AI Infrastructure, and today I have Schneider Larbi with me, who's a senior manager of Global Partner Technical Architecture. Schneider, do you want to introduce yourself and what you do day today?
Thank you, Chelsea. And as Chelsea said, my name is Schneider Larbi. I lead the Global Partner Technical Architecture team responsible for co-innovating with our strategic ISVs. And I'm happy to be here today to have a chat with you, Chelsea.
Same. So, I've been hearing all the hype lately is on agents and agentic workflows. I'm so focused on hardware all day. Could you give me a high level overview as to what an agent is? And then we can get into why it's so popular.
Okay, it's a question many people are asking today, and the simplest way to frame it, we all know what a chatbot is. Chatbots came around a while ago, and chatbots usually would give you an answer when you put in a question. But an agent actually accomplishes something, right? When you make a plain large language model call or an LLM call using a prompt, right? You enter in an information and ask a question, it returns with a text. That is a simple chatbot. But when we talk about an agent actually has the capability to take a goal and then plan for that goal, takes actions, observe the results, and it actually loops through a reasoning loop. And then it's even able to act, observe, and repeat until that goal is actually done, right? And what helps this agent to do this is that the agent has been built with a couple of components. The large language model being the brain of that agent, and then every agent does have instructions that defines its job and what the agent is capable of doing, right? And it also has what we call tools. And these tools is what allows the agent to take action on a specific goal it's trying to achieve. And then finally, there is the orchestration layer within the agent, and that is what runs the loop and coordinates everything that the agent does. So, in a nutshell, this is what an agent is.
Awesome. That explains it. And then why is it getting so popular now?
So, three things converged, right? The era of, AI models has been around for some time now, and the popularity has continued to grow. But actually, now these AI models finally got good enough at reasoning and tool calling that you can actually trust them to do multi-step work instead of just one-shot transactions. So that is one. And second, open protocols have also standardized the way we do things today. If you think about Model Context Protocol, what we call the MCP, it allows these agents to connect tools and data. And if you think about agents to agents protocol, which we call the A to A, it gives agents the capability to talk to one another, right? So all of this glues these agents together and it makes them very powerful in what they can do. And actually, thirdly, there is also the platform layer, which has matured. Today on Google Cloud, Google built what we call the Agent Development Kit, which is actually a framework that allows you to build these agents. And on top of that, there is also the managed runtime and what we call the Gemini Enterprise Agent Platform, right? So now you can actually deploy, govern, and scale these agents at scale, right, at the enterprise level. And so right now, agents is not about something that we do for, simple pilots within organizations, but agents went from a cool demo to a deployable distributed systems that adds value to businesses today. It's why you're hearing all this hype around it.
100%. And that explains everything. And then how do you think, or how would you think about the underlying infrastructure when building agents?
So, two big shifts here, right? And the first I want to touch on is on inference. We've moved past just, build a bigger model and let it do everything. The frontier now is giving the model compute time at inference, and it is what we call the test time, or let me say, thinking compute. And for instance, if you take something like, Gemini 3, which is Google's model, for instance, it has a thinking budget. And what does that mean? It means that it can spend before answering. So your own example that you give it, instead of letting this LLM think or guessing the answer through a hard math or like a coding problem in 2 seconds, an agent has the capability to actually write a Python script. It can actually execute it in a sandbox, read an error log, fix its own code, and returns a verified answer to you. So it deliberately trades raw throughput and token for far higher accuracy. And from the infrastructure standpoint, that actually changes everything, right? That allows for longer running sessions, more tokens per task, higher latency tolerance, and hard requirements for sandbox code execution, right? So at the inference layer, this is how it ties in when it comes to agents. And the second thing that I want to also highlight here is matching compute to the workload. And the
Mhm.
key insight for builders is that, not every step of an agent actually needs a GPU or a graphic processing unit, right? The orchestration, the two calls, the glue logic that runs an agent can actually run on a normal CPU, right, without having any issues. And you actually would have to reach for accelerated compute, which is a GPU or a TPU at the model inference layer, right? And the type of accelerator actually depends on the job that this agent is doing. So, for example, if you are building agents like agents that handle drug discovery and simulation use cases, these kinds of agents require high throughput, high bandwidth GPUs with strong parallel processing and sometimes ray tracing capabilities. And that is where something like RG4 GPUs with the NVIDIA RTX Pro 6000 comes in, right? If you talk about agents that handles only text or what we call the LLM agents, they often do not need that profile at all, right? They simply call like a managed model API and then let Google handle whatever is underneath that. And then we also have CPU versus accelerated compute, right? And this is actually the what I call is the first fork because TPUs are actually for high throughput. So for example, is what we use for serving Gemini. And then the GPU portfolio also works with partners, open, and even specialized workloads that we have on top of on top of Google Cloud. So the mental model that I actually leave people with here is that an agent isn't actually one process that you size for. It is actually a distributed system. When you build one, you're actually provisioning, serving, and a memory state store and two sandboxes and the network between agents. And the underlying infrastructure would depend on the specific use case that you're building it for.
Oh, that's great, and it's so true. There's so many different types of underlying compute that you can match up to the type of the agent from using our standard compute, workload optimized, or even if you need to get that accelerated computing, we have a whole wide range of portfolio of options to help with the accelerated side as well. So,
Yes.
when you're looking at deploy these, what are the different types of deployment methods, and how do you choose between them?
So I actually like to simplify this, right? There are actually three main paths of deployment on Google Cloud because I'd like to restrict our conversation here to what happens on Google Cloud.
I
And they
think that's
actually
fair.
and they actually, sit on a spectrum from serverless simplicity to having maximum control. So let's take one of the deployment patterns like Cloud Run. So Cloud Run is actually one of the fastest path to deployment of agents on Google Cloud. And it actually is a serverless service, managed service that we offer on top of Google for compute. It's got this capability to even scale to zero. And you can stand up an ADK agent with its API, web UI, and even an A2A endpoint from a single container to it, right? And even within an ADK has this wrapper that even allows you to auto generate an auto card, or what we call the agent card. And you can use that to serve your agent at scale to multiple users on Cloud Run, right? And I usually say that if you want to use Cloud Run, use it for spiky, or I would say like variable traffic, or when you are cost sensitive, or if you want to get to production very quickly without having to manage infrastructure, right? So this is one deployment pattern for agents on Google Cloud. The second one that I like to talk about is the GKE Agent Sandbox, which actually became generally available not long ago. And actually, that uses a gvisor kernel isolation, right? It is almost the same tech that secures Gemini to safely execute untrusted or agent generated code, right? And so you choose this method of deployment when you have a scenario where your agents run generated code at scale and you need strong isolation and full control, right? So we have customers like LangChain and Lovable run millions of agents on it, right? So think of it as a secure code execution substrate, right? Where you would want to run agents. So that is another deployment pattern. Then the other one is the agent runtime. So I want to give you a heads up here. This was formerly known as Vertex Agent Engine, right? But right now it's branded Agent Engine Runtime. And what that does is that it is also like a managed service for agents. But the advantage that that gives is that it is scalable, it's got managed runtime, and the value that adds to the deployment is that you're able to manage sessions, have the capability to give memory bank to your agents. You can even have observability and tracing, evaluation of your agents, using IAM agent identity, and so forth, right? And this is very useful for enterprises when they want memory and governance baked in rather than having to build it by themselves. When you do that on, Cloud Run, or, the sandbox that I'm talking to you about. And then the fourth one that I want to talk about is the raw GKE, which is the Google Kubernetes engine. So this allows you to simply deploy your agents on it, and it gives you the maximum flexibility, right? Because you're able to build a lot of customizations, because Cloud Run, the sandbox, and the agent engine runtime are kind of opinionated, right? They are fully managed. So there are not many things you can do there. There are some things you can do and some things you cannot do. So, one example, let's say you're building agents that have the requirements to use some specific type of GPUs, right? You cannot do that within the agent runtime. You can select a GPU. For Cloud Run, you can select some GPUs. I think RTX is available there today. But
Yes,
what if you
G4 is
need
available.
exactly? Yeah. So let's say you need, the H100 and whatever, that might not be there. But if you want this kind of flexibility, GKE is your friend. That is where you want to go, right? So the way I put it is the easy way for choosing which deployment pattern is Cloud Run. Use that for serverless speed. Use the agent runtime for a managed enterprise runtime with memory and governance, and use the GKE agent sandbox for secure coding execution at maximum scale and control.
Mhm. Those are excellent points. And with Cloud Run, you were just making me think of Able. They build their agents entirely on Cloud Run, and they just moved from are the L2 GPU to our G4 instance, which is the RTX 6000 Server Pro Edition, NVIDIA's GPU. Um, and you brought up a good point about the secure code execution. How do you think about security when you're designing and building out the agentic architecture?
So security has to be woven into every fabric of it, right? From the underlying infrastructure ground up. So, for example, if you're running on top of the Gemini Enterprise Agent Platform, we've built it with security in mind ground up. So we've secured several things there. But even where you want flexibility and building things on your own using GKE among other things, you can use things such as confidential compute right at the compute layer, and use various encryption techniques and technologies and products that we have on top of Google Cloud to ensure that you're building things securely. Now, when you come to the networking layer, this is also a place where we do have our VPCs, or what we call the virtual private cloud, where you deploy these things, and you have the ability to configure service controls within this VPC to create a perimeter around your deployments to ensure that you secure it that way. Additionally, you can use services like identity and access management. You can use firewalls, among other things, and different types of authentication mechanisms. And when it comes to building, ground up, we go into the agents itself at the application level. You also want to make sure that you're using different authentication mechanisms between these agents to ensure that they authenticate to each other securely. And on top of that, with the Gemini Enterprise Agent Platform, we've given you all of this, right? So it's just a few clicks and a few configuration, and you can stand up all of this security posture to allow you to secure how your agents communicate. And even on another layer on top of that, you can use techniques such as OAuth, authentication mechanisms to ensure that authentication into your agents before use is also protected. And we don't want to forget things like external attacks. So we do even have model armor, which is also available on the Gemini Enterprise Agent Platform, which you can configure and ensure that your agents are also secure from the edge, right? When the traffic is coming through, to ensure that there are no prompt injection issues, among other things. So from the way you're looking at it, security is very crucial, and we've allowed you to be able to do that on the Gemini Enterprise Agent Platform. And we've also added governance to it to allow you to have an auditable trail to understand the posture of how you have built your agents and how they work together. So from I've said a lot, but now the goal here is you're starting to see that when you run on top of the Google Gemini Enterprise Agent Platform, you have all of this at your fingertips and a click away to deploy and to make sure that your agents are secured, rather than having to do it from different services, using different things from different places, adding several management overheads to your operations.
And Schneider, you said something really near and dear to my heart, the confidential GPU. You can actually use that on G4 GPUs right now, or the NVIDIA RTX 6000 Pro. And what it does is it protects the confidentiality and integrity of that sensitive data in the AI workloads and minimizes the threats to the unauthorized access on the GPU. And you can leverage all of that with no code changes underneath, which is pretty nice when you have something already built out. But I
And
also
that,
wanted to, oh, go ahead.
yeah, I was gonna acknowledge that. That's amazing. That's all.
Yeah, that's a huge win there. And there's something else I wanted to go back to is earlier you said the brain is the LLM. So what do you think we should do? Do you think you should train your own model, fine tune it, or use RAG?
Well, I mean, I would like to share my own, biased view about this matter here with you. So, with the proliferation of large language models everywhere today, I personally don't think anyone should literally train one from scratch, right? The real skill is actually matching the technique to the gap that you are trying to close, right? And what do I mean by that? Let's think about it this way. When we go into the model garden today on the Gemini Enterprise Agent Platform, um, one way you can start by consuming large language models out of the box is through what we call the model as a service, right? So when you go onto that platform today and you start using, Gemini group of models as an example, or partner models like Claude on Vertex, or plus the many multiple open models there like the Nemotron models from NVIDIA, among those things. Those are all, you're using them as a service, is being offered to you. So there is zero infrastructure for you to manage. You usually would have to pay per token for some of them, and this is what I would say is a default, starting point where most production agents should live, right? You did bring about RAG here, which stands for Retrieval Augmented Generation, and it is usually actually used for grounding to reduce hallucination of AI models. And when that is used, it means that it helps the agents to ground its responses to whatever factual data that is available. And RAG isn't really a model choice, it is actually an architecture, right? Use it when the gap is knowledge and not capability, right? Ground the model on your own data using the something like Vertex AI search instead of retraining something from scratch. It is actually the cheapest way to make a general model understand your domain from
And we
which
all
you
want to save some
operate.
money.
Absolutely, absolutely. We want to do that. So that's what I would say about RAG. But when we talk about things like fine tuning, right, use it for when the gap you're trying to close is actually about the behavior, right, of the model. So, for instance, if you have requirement for like the need for a consistent format, tone, or domain style that prompting plus RAG can't reliably produce, then think about using techniques like supervised fine tuning or low ranking adaptation, which we call the LoRa on the platform to achieve these things with your model, right? So that's another thing. And when you need like a specific open or custom model to address use cases such as data residency requirement, or you even want to do what we call custom serving, or you have the volume where owning throughput is the better economics for you, then you have the option to also rent the accelerator, which means that you own the serving stack. And this is what I call, or we usually call that, the self-host on the Gemini Enterprise Agent Platform using the model endpoint. And that gives you something like GPU as a service, right? Because today you can create an endpoint and back those endpoints with the G4 RTX Pro GPUs, right? And then it exposes that endpoint for your model to do the inference from there, right? So that is the other option there. And so when it comes to, having to train your own, I would say, train your own only if you are a frontier lab
Mm.
or you have a deeply specialized problem with massive proprietary data, right? Or, rare, expensive, I mean, something like that that is really rare and expensive, right? Because if you want to do full training on your own from scratch, it can be expensive. So I would say if you want to do your own training, that should only be the factor, to justify some of the costs involved in doing that. So when we look back at what I've just said, the decision tree is when there is a knowledge gap, use the RAG. When there is a behavior gap, use fine tuning, right? And when there is a capability gap, reach for a better model using model as a service. And then when we're talking about control or residency, use the self-host method. And then you will be able to use these models in a way that is economical and adds more value to what you're trying to do. So the key here is to start managed and only move down the stack when there is a real constraint that pushes you to do so.
That is a really pragmatic way to go about it. Um, could you walk me through how would you build an agent from the literal ground up of infrastructure?
Yeah, so that's quite a number of steps involved in doing that. But
Oh, we
when
can
you
break
say
it down
build it,
then.
yeah, let's break this down here as to how you would want to do that. So the first thing is you need to think of where you want to run your infrastructure. And again,
Google
I'm going to
Cloud.
be biased. Absolutely, absolutely. I'm going to be biased about that. You read my mind here. So Google Cloud is where you want to run this. But then the first thing is we need to first of all define the goal and the scope of what this specific agent is going to do. As in, like, what is the task? Um, how does it look like when it is done, and everything else about the capabilities of the agent, we need to define it. Then you now need to pick the brain, which is the large language model that this agent is going to use. So the easy way to do this, go to the Gemini Enterprise Agent Platform and grab a model from the model garden, either through the model as a service model, or you can start with Gemini or Claude on Vertex, among other models, Nemotron, and so forth. Pick the one that works for you. And if you're using the model as a service option, make sure you understand, you extract the endpoint IDs and details about the model, because the model has to be exposed to your agent in order for the agent to make inference to it, right? So once you pick the brain, you need to get all these details, and this is very high level, of course, right? There are a few bits to it, but then you come to the build phase where there are several frameworks for building agents, but again, I would always stick to Google. I love to use our agent development kit, which we call ADK for short. And when you use this ADK, what it actually allows you to do is to define the instructions that we discussed earlier about how you want the agent to behave. And then within that ADK framework, you're able to wire up your tools, right? This could include your own functions, or you can even use MCP tools that are managed through, cloud APIs or different, MCP servers out there. And then you can set the orchestration as to how you want it to work. And when you're building enterprise grade agents, think about building a multi agent architecture. So that would mean that you have to think of how to build your orchestrator agent that would work with different sub agents, either sequentially or in parallel, right? So you have to have that in place, and you build all of this using the ADK. Now, a critical piece of an agent is, I think you remember when these chatbots started coming, and even today you can find some agents that are like that. You can tell the agent something and you ask the agent, "What did I say?" And the agent will tell you that I have no clue what you told me, or it will repeat something to you, please, introduce yourself again or something. Agents
I find
behave
that
that way.
sometimes the chatbots that are powered by agents actually work now. It's a miracle.
Yes, right. And agents do that when they do not have memory, right? So
Mhm.
to avoid that problem, we give the agent memory. And so we define or build sessions for state within a conversation. And that is where memory banks comes in for context that persist across different conversation sessions. And you can do this easily out of the box when you're using the agent runtime platform as your runtime for this agent. So once you have all of these things defined and built into your agent, The next thing you want to think about is to make your agent interoperable because, like I mentioned in the onset, we are not at the stage of building, proof of concepts and pilots any longer. We are building enterprise distributed systems that takes real actions and add real business value to organizations. So when you are done building an agent or in the process of building an agent, you need to think about wrapping your agent with the agent to agent protocol, or what we call the A2A for short. And when you have this A2A in place, that means that your agent can be discovered, right? What does that mean? That means one agent can call your agent and get more information using something we call an agent card in order to allow them to communicate. So let me give you one typical example. Today, you can have one agent here. Let's say you have an agent for a small retail shop. You can tell the agent, hey, how are my inventory levels? And then the agent can tell you what it is, and you can say, okay, I'm running low on t-shirts. I want you to reach out to my t-shirt supplier and get me more t-shirts. The agent will use this agent A2A capability to reach out to the vendor if that vendor also has agents that are A2A compatible, and it can give that order to that agent, make the order on your behalf, and then send the details back to the agent. So A2A allows your agents to talk. It makes it interoperable, and that is now allowing agents to work with other SaaS systems like Salesforce, ServiceNow, Workday, and different systems, and integrating all of that. So today, when you're building agents, interoperability is a big thing to consider, right? Then once you have all these pieces together, now you need to deploy it. And we discussed about the deployment patterns, right? Depending on the use case, you can either, put this into Cloud Run, Agent Engine Runtime, a GKE sandbox, or you can put it on GKE just like that, per the trade-offs and the different type of use cases that we discussed. And additionally, it doesn't end there. The most important thing you also want to factor in is how do you govern and have visibility and observability into your agentic distributed systems and how it works. And again, we've made this very easy for you on the Gemini Enterprise Agent Platform, right? You can register your agents there into the agent registry. You can give it an IAM agent identity, and then turn on tracing and evaluation, and even let Security Command Center watch for threats, right? So these are some of the ways you can govern agents after you have deployed it, especially on the Gemini Enterprise Agent Platform. And then I said it already, you can surface it there when you register it. What that means is other businesses can then talk to that agent and consume it using agent as a service model. So today, when you go to our agents registry or the marketplace, you are going to see several agents from different ISVs doing several different things. And you can call these agents and use their services to do what you need. So that eliminates the needs for you to now build highly complex agents that are not in your domain. You can now build something and use it to pull what you need from a vendor agent and bring it back within your own organization. So, at a very high level, these are the processes involved. And when you're done with all of this, you need to iterate with evaluations, right? To make sure that your agents are always performing. The thing that I would actually emphasize is, notice how little of this AI magic is and how much a classic software engineering is like. In that world, we have identity, runtime, state networking, observability, and so forth. And so that is the whole point of this platform shift, right? We are treating agents as a first class distributed system citizens, which is exactly why the infrastructure conversation you and I are having matters today. And all of that ties into building agents today for the enterprise.
Oh, very cool. So now, are we ready to vibe code yet?
Absolutely. I would like to show you a demo that I have built of a multi-agent system. It is actually designed to address a drug discovery use case, and you're going to see how it all works together. I'll share my screen now, and let's walk through that.
Great, thanks.
This is the Gemini Enterprise Agent Platform that I have been talking about during our discussion today. And this is actually the platform that allows every organization to centralize and govern all agents that they build. And like you can see here, this part that says made by Google, these are Google managed agents that comes with the platform when you subscribe to it, right? The deep research agent, notebook LM, idea generation, and whatever new ones that we include. But what we are actually interested in is this portion that says from your organization. So this is where all agents within a specific enterprise that is registered to this platform will be published, right? When an agent is registered, it would all appear here. And then an admin can make these agents available to every employee or each employer who is supposed to have access to it. Here, I'm going to talk about an agent that I've built to address drug discovery, as we were discussing earlier today. And the name of that agent is actually this Moforge. And don't ask me, I just made up the name. And this is how you actually interact with with the agent. You click on it and you can just start interacting and typing to it and talking to it.
I see you're using NVIDIA Nemotron, Genmol, DiffDock to build this agent. Now I know NVIDIA Nemotron's coming from the model registry on Gemini Enterprise Agent Platform. Can you explain the design pattern and how you're pulling in Genmol?
The way we've done the gen mole is we're using the NVIDIA inference microservice, and these are package containers that contains the model with its inference engine. They are highly optimized, and we download that from the NVIDIA NGC catalog, and we directly deploy that to the Google Kubernetes engine. And we did that actually onto the GPU node pool in that cluster, and it allows the inference to be done to it. It exposes, an inference endpoint, and then the inference is made directly to this model, and it's also powered by the GPUs within the Google Kubernetes engine, right? So this is an underlying infrastructure that is powering the Genmo. So I'm actually going to put a use case here. I'm going to tell this agent that I'm working on a chronic myeloid leukemia drug discovery project. Can you fetch the human ABL1 kinase amino acid sequence from UniProt? Right. So this UniProt is actually a curated database that actually contains a lot of protein sequences and samples that are used for medical research. It is a public database. You can go there and do that. And under normal circumstances, any researcher will have to go to this website, have the right, protein name, and they have to search through it to find a target, right? A protein target they're trying to fix, or let me say, create a new medication for. But in this case, you see that we have a multi-agent architecture here where we send this information first to the orchestrator agent, which is powered by Gemini. And then it has another agent, which we call the lead agent. And that agent is powered actually by the Nemotron model. And what that agent does is that it receives this, and that agent has got a tool. And that tool allows the agent to connect to the external world into this UniProt database and look for that information. And look at how intelligent this system is. First of all, I did this on purpose because there are multiple types of this ABL1 kinase amino acid.
but you can see here that it's starting to search and it says that, oh no, I found something else. And then it kept iterating until it found the correct ABL1 Kinesi that I am looking for, right? Because I am looking for one that is applicable to humans with this UniProt ID, right? So even though I didn't have the UniProt ID, the agent was intelligent enough to iterate its search and make sure that we have all the right details. And it pulled that information. And we can see that this is for Homo sapiens. We can see, the sequence length of this amino acid, and then we can see all the amino acid sequence displayed to us. All of this was done through orchestration, and this information is passed on to us right here in Gemini Enterprise Agent Platform. But now, the next step we want to do here is that we want to think about how to improve this medication, right? So I actually have a curated prompt that I'm going to put here. And this is what the prompt says, right? I'm saying that this is a known drug, which is this imatinib, and this is the SMILES ID for this specific drug here. And what I'm asking this agent to do is to dock this drug against the experimental crystal structure of this protein. And the way to do that is that we have to use the DivDoc model to do it. The DivDoc is capable of doing that. And then we want to have 10 different poses, right? And I also want to see how the existing drug binds with this protein before I think of designing any new improvement for this specific drug. So when I hit this send, this goes to the orchestrator agent. The orchestrator agent starts to think which of the sub agents is responsible for doing docking. There is an agent for that. So it uses a tool call, right, to get to that agent and tell it that I want you to get this information and then make inference to the DivDoc model and execute what I'm asking you to execute. And then that is what happens. It sends that to call to it. And then using that to call, it makes inference to the model. And now remember, Chelsea, that this is highly computational because it is going to do this docking through the folded protein structure to find areas around the protein where you can dock, this medication in order to understand its behavior before you try to do anything with it. And so you can see that we have all the complete details here. Um, and it's telling us that it is using the NVIDIA hosted DevDoc name to do that. The time of inference, 2 seconds, right? You can see these details here. And we have all of that here. But more importantly, we have also incorporated A to UI, which is agent to UI functionality into Gemini Enterprise Agent Platform. So you can see that that rendering was happening in the background and it has created the folded protein with the spots on that protein for binding of this specific medication, right? Isn't that amazing? And you can see that now this agent is not doing a very simple API call and sending, text responses. We're doing inference, heavy computational inference that involves, binding of proteins, docking, folding these proteins, and then all of this computational information is being relayed back to the agent. So this emphasizes what we were talking about, that with a use case like this, the underlying infrastructure that powers the agent has to be built right to address a use case like this, like we were talking about. And also another thing, this is the A to UI rendering. This A to UI is very new. So sometimes the UI is a bit wobbly, as you see, but the agent also gives you an option to actually see what the agent, or let me say, what the model itself can show. So when you click this open the docking post viewer, it actually gives you a new tab that allows you to interact with the um, this protein that has been folded. And this is how it looks, right? So without A to UI, this is the option you have to interact with this folded protein in order to understand the bindings. And the GPU is what is helping us to make this rendering. We have the capability to move this around, and when needed, we can enable ray tracing among other things over here, like you can see, right? But the Gemini Enterprise Agent Platform is allowing us to even do that inline here, using the A2UI capabilities. Right, right. So now that we know this, the next thing I'm actually going to do is that I'm going to ask the model, now that I understand the way this medicine binds with it here, right? It's giving me all the confidence score and all that. I'm now going to put in this prompt here. And I said, okay, now I want you to optimize this imatinib medication against this protein for the chronic, leukemia therapeutic area. And I wanted to actually generate 8 variants of new drugs that are focused on improving binding affinity, reducing inhibitions, and we want to provide a full analysis of this. So we send this to the agent, and this is actually one of the very heavily computational activities happening here. Now we are making inference to multiple areas, right? First of all, a tool call is sent to the another model, a sub agent that will make a request to the GenMol NVIDIA inference microservice running on the GKE. That is going to cross-check this imatinib medication, understands its chemical composition, and also understand some history around this medication from the protein sequence from UniProt. Another agent will run in parallel and pull that information for that agent. And then what happens is that it starts to use different chemical compositions to try to generate new drug candidates of this existing medication in order to be able to come up with something new that can improve this existing medication with the binding affinity improvement that I'm looking for, as well as the ability to reduce inhibitions.
Now, I imagine if you're doing this manually, this would all take hours. I'm surprised how quickly you can operationalize the research and also synthesize the results. There's so much happening behind the scenes that you no longer have to manage.
Because as I said, this is highly computational, we are also doing a lot of rendering in the backend through the A2UI to display this, bindings. These are the 2D renderings, so it is showing all of it here. But let's go through this responses. You see that it says I will now delegate the orchestrator agent delegated this to the lead optimization agent. That agent used the underlying brain, which is the general model, to generate 8 optimized variants of this medication against the protein target we selected. And this optimization is focused on what we exactly asked it to do. So you can see that even though we are having all these 2D structures here in the source gallery, we have an open doc. We have the ability to open it and we can look at it as well. And all the analysis, we have the executive summary, and these are the new drug candidates that have been created, and they have been ranked as well according to their properties and how they perform based on the um, constraints and the criteria that I set for this. So you can see all of this details coming here, and the agent even telling us what is the next step to take as well. So you can see all this 2D structures here. Take a look at it. And here we have the 3D structure is here as well. You can find that information. And if you need to go more deeply into it, you can open this 2D source gallery. So when you click on that, what that actually give you is the full report, right? You can also see that, and it contains a lot of the all the properties here that couldn't fit into that screen. It is organized very nicely here, and it gives you the ability to like print it or export it or change it into whatever format that you need. So you have that option as well. And if you also look at a 3D docking viewer, just like we saw, you can also see the 3D docking. You see that? And you can now see all the different candidates here, and you can select all of this to understand how they interact with this over here. You can also see all those details as well, right? So this gives us a high level understanding of what is happening in the back end and all the computations that these agents have to do. So now what I'm going to ask the agent is that of this 8 variants, right? When you make any drug, it is not useful if that drug would interact with another drug in a bad way, or that drug can impact another part of the body in a bad way, right? So here I'm saying of these 8 variants, pick the top three. And I'm particularly concerned about the cardiotoxicity of this kinase inhibitors because they have that history, right? So I want to understand the side effects of these drug candidates, especially the top three picks. I want to understand how that would impact, the heart for users or for people who take this drug. So again, instead of going through a lot of manual researches to do this, I just tell the agent to do that. And the agent is going to pick this top three that came up as we saw here, right? This top three, the agent is going to pick it, and it is going to do all this synthesis in the back end. Is also using another agent, and is using the admin system that we have inbuilt there also on the GKE cluster. And it is going to compare different things to it and make different kind of computations. And these computations, again, are highly intensive. And it happens and it will generate all the report that I need, and it will bring it here for me to understand it, right? And then after that, I can ask it whatever else I want to ask. So we give it a few seconds for this operations to also complete. Yeah, so you can see that it started giving us all the results, and these are the top three. We see the rendering also happening here, and you can find all this information here. It gives us all the summary about each of these drug molecules and what they do, and it is quite comprehensive. And the last thing I actually want to say is based on what you found, which of those candidates would you advance into, vital testing first, and why? Walk me through your reasoning. So here, I'm not even going to tap into all the other protein-based models anymore. I'm actually tapping into the reasoning capabilities of Gemini. So this is not even going to be passed on to any of those models. Gemini is actually going to take this and optimize everything. And here is where you're seeing another capability. The agent remembers all the discussions we have from the top down to this point. And so it is able to pick what we did in the beginning, compare it to the safety assessment, and then it's able to give us recommendation, right? And now it's even telling us unequivocally not to advance with any of these three candidates for vital testing. And it is giving us its reasons why, because of the high inhibition rates and so forth. And I picked something like this that could help us to see that the model really understands what it's doing, and it is actually accurate in terms of this research that is required in the drug discovery process. And this is the value that enterprises can get out of this. Imagine having 100 plus researchers working together on a project like this and using agents in this manner with powerful models and underlying infrastructure in drug discovery, right? The possibilities are simply endless, Chelsea.
All right. So, Chelsea, what do you think about it?
That was really cool, and I can't believe how simply you brought it all together.
Yes, it's really amazing how you can do this. And as you see here, all of this is operating within the Gemini Enterprise Agent Platform. I didn't have to get out of this platform to anywhere else to get whatever I need ground up, from the GPUs to the infrastructure, the GKE, to the agent runtime, to the orchestration from ADK, to the A2A protocols, and for the governance, security, everything in one place in a scalable way and in a secured way for the enterprise.
Now, that's impressive how it's all Google made, Google built, Google hosted, Google managed.
Absolutely. And so, my message there is we invite everybody to come build agents on Google Cloud on the Gemini Enterprise Agent Platform. I urge everyone to take a look at it. It is really amazing what businesses can achieve with it, the value they can add to what they do, and it's really something to look into today. And so this is what all the agentic hype you're hearing is about. And this is just the beginning. We are just starting. There is more to come.
Yeah, it doesn't sound like hype at all when you break it down. So thank you.
Yes, absolutely.
Well, thank you, Schneider. I really appreciate you taking the time and walking us through everything. It really doesn't seem like hype after all when you break it all down. Thanks everybody for watching, and stay tuned as we dive into some more conversations.